Okay, chapter 8, study guide. It says the length of the rectangle is 9.5. The width is 4 1/4. What is the ratio using whole numbers of the length to the width? So here we go with number 1. And they give us the length, 9.5, to the width, which is 4 1/4. But they don't want fractions. They want whole numbers. How are you going to do that? Yes.
You just make 9.5, 9 2/4, and then you just make them into improper fractions.
Okay, so I make 9.5 and then 9 2/4, so I get a common denominator. Okay, and then?
And you turn them into improper fractions.
So tell me how to do that.
So 4 times 9 plus 2 over 4.
38 over 4?
Yeah. And then the other one's going to be 17 over 4.
Okay, they're not whole numbers yet.
But that ratio would be 38 to 17.
Okay, how come?
Because you multiply by 4.
Or I could do, yeah, you're exactly right. Or I could say 38 divided by 4 divided by 17 divided by 4, which is 38 divided by 4 times 4 over 17.
I think just multiply by 4 is simpler.
So we get 38 over 17. Number 2. A over B equals 8 over 7. Then 7A equals, now this one, super easy. First one was hard. This one's pretty easy. What's the answer here? 8B. Number 3, solve the proportion. 3 over A equals 6 over 14. What's your method for doing that? Who's got a strategy for that? That's a 3.
Seven.
How
A
do you,
is 7.
A is 7. Tell me how you know that, Colin.
Well, the top number is 3, and on the right it's 6. And 3 times 2 is 6. So that means 7 times 2 is 14.
Yep, exactly right.
Duh.
Number 4.
Sorry.
That's okay. On a blueprint, the scale indicates 4 centimeters represents 11 feet. What is the length of a room? That is 5.2 centimeters long and 3 centimeters wide. How many proportions do you have to set up and solve to answer this problem? 2. A lot of times kids will mess up. They'll try to take 5.2 and 3 and make them into some kind of ratio. They're not this. We're talking about scale. We're not talking about length to width. We're talking about real building to the drawing, relating those distances, not length and width. So what we'll want to do is we'll want to set up 5.2 centimeters to how many feet is equal to 4 centimeters to 11 feet. And what's the process here? Process. What do you do? Cross multiply. So we get 57.2 equals 4x divided by 4. And x is 14.3 feet. So this is one answer. We have to do the same process again. 4 centimeters is to 11 feet, as 3 centimeters is to x feet. Same thing. 4x equals 33. Divide by 4. X is 8.25 feet. Those are my 2 answers. For number 4. What's the question asked at number 4, though? They ask for specific. What do they ask specifically for? Length is what. Well, they ask for both. No, they ask for length. They ask for length. Number 5. Are the polygons similar? If they are, write a similarity statement and give the similarity ratio. So in number 5, they tell you, they describe this triangle. And it says it's triangle RST. RS is 10. RT is 15. Measure of angle R is 32. N, U, V, W. UV is 12. UW is 18. Measure of angle U is 32. Okay, I have matching angles.
Wait a second. What's
So-
number 4?
Number 4 was 14.3 feet. I have matching angles. So I'm good on that. Now what I have to do is see if the sides are proportional. So, is 10 over 12 the same as 15 over 18?
No.
Do they have the
Hey,
same
oh.
ratio? How do you determine whether they have the same ratio? You can
course.
simplify them, or you can use their cross products. If their cross products are the same, is 10 times 18 really equal to 12 times 15? Yes, it is. So yes, the sides are proportional. So triangle RST is similar to triangle UVW. What is the ratio? Well, if you reduce 10 to 12, you will get 5 to 6. That is your ratio. That's number 5. ABCD is similar to WXYZ. AD is 6. DC is 3. WZ is 34. Find YZ. Doesn't have a Y on there, doesn't it? Does it? That must be WX. There's the Y right there. That's the one I'm looking for. How do I set this one up? 6 over 34 equals 3 over the missing side. 6 times the missing number should equal the product of 34 and 3. And that is 6 times something is 102. I got, that is 17.
Oh, hold on. Let me write all this down, please. Just we have to move the test.
No. Number 7. You want to draw an enlargement of a design that is printed on a card that is 6 by 7. So I've got a card that is 6 by 7. I want the enlargement to be made to an 8.5 by 11 piece of paper. What are the dimensions of the largest complete enlargement you can make? What can you do? What can you do?
Ratio it.
What are the dimensions of the largest enlargement you can make?
8.5 by something.
8.5 by something, right?
8.5 by 9.5.
I can turn 6 into 8.5. If I turn 6 into 8.5, what have I done here? 6 is to 8.5 as 7 is to I don't know what. I've got to figure that out. So, what do you do to figure that one out?
Figure that out from the get-go. Sorry, number 6. I'm just saying I could have figured out number 6 from the get-go.
So I get 9 and 11 twelfths. So the dimensions would be 8.5 by 9 and 11 twelfths. If I had said, well, I'm going to turn 7 into 11. Okay, let's just look at that. 7 is to 11 as something is 8.5. And worked this one. I would have gotten this to be 5.4. So my options were 5.4 or 5 2/10 by 7, or 8.5 by 9 1. That's the larger one. That's what they're asking for. That's why that's the answer. Okay? If I had checked the other one out, it would have been a smaller version. Number 8.
That's number.
An artist's canvas forms a golden rectangle. The longer side of the canvas is 32. What's the shorter side? What's the golden rectangle?
About 1.6 ratio.
Oh, I need to do long to short, though. So what do you do here? 32 divided by 1.6 is really close to 20 inches. You could have gotten, depending on whether you use 1.6 or 1.68 or how far you took that decimal, depends on how accurate this number is. So, yeah, I did 32 divided by 1.6 and I got 20. My book says 19.8, so it just depends on how closely you use your values. 9. In triangle QRS, QR is 16, RS is 64, R is 29. In UVT, VT is 8.
So 20
T
inches is number 8.
Mm-hmm.
Then what's number 7?
You got it on that piece of paper.
5 2/10s.
Okay, here we go. Number 9. The question says, state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem that you use. Do they have a matching angle? Yes. Is 16 over 32 the same as 64 over 8? Is that the same relationship? No. So they are not similar. 8 times 16 is 128, and 32 times 64 is 2,048. And those products, 8 times 16 would need to equal 32 times 64. Cross products would need to be equal for them to be similar. 10.
You probably recommend writing out a triangle and you recommend writing out a triangle?
I do. Number 10 says explain why the triangles are similar. Find the value of x. Well, first of all, they have those angles that are congruent because they're vertical angles. If you have two angles in one triangle congruent to two angles in another triangle, guess what? All three angles are congruent. So what we have here is a postulate that says if two angles of one triangle match two angles of another triangle, they're proportional. So it's the angle postulate. So to find x, I would need to set up x over 10 equals 17 over 25. Use my cross products. And I get x to be 6.8 or 6 4/5. 11, well, that angle, I'm going to draw these separately. There's the big angle. It's 8 by x. There's the little angle, triangle. It is 5 and 7. They mark these parallel. When it's marked parallel, you know that those angles there are congruent. So we have angle postulate again. So they are similar. So 5 is to 8 as 7 is to x. Cross products. Divide. X is 11.2. Questions on number 11.
Where's the 8? So it's 5 over 8.
Here we go. 12. Use the information in the diagram to determine the height of the tree to the nearest foot. What you have is two similar triangles here. Okay, we want to look at that. This is 120. This is 120. So I have a tall triangle that is 240 by 160 by 144. It's 140. It's not. It's 144. It's 288. I have a smaller triangle that is 160. No, it's not. That's the tree. And this is 120. And this is 144. And this is T. So the triangles are similar. So T over 160 is equal to 120 over 240.
And T equals.
We're about to discover it. T is equal to 80. Number 12. 13 asks you for the geometric mean. To find the geometric mean, you multiply the numbers together and you
Number
take the
13?
square root of their product. Number 13. I'm on number 13 now. It's
Did you say number 12?
it's 80.
I know, sorry.
So it's the square root of 169 times 9. And the answer there is 39. Geometric mean. Everybody caught it with me?
Not. I have not done that problem yet.
Just multiply the square root.
Solve for A and B.
5.9. Whatever. Oh, what's this here?
Okay, these are similar triangles, but they're oriented differently. So I'm going to pull these apart. Okay? You see how I pull those apart? What's the hypotenuse in this triangle? 10. Ooh, I did not mean to make that orange. Thought it was going to be yellow. 10 is the hypotenuse. So what's the hypotenuse in the other triangle? B. So they're going to match up. B over 10 is a ratio. What is an angle that is touching the angle? What is a side that's touching the angle that's marked? 6 and 8. So 6 is to 8 as B is to 10. And as A is to 6. So you need to solve two separate proportions. The first one here, 8B is equal to 60. Divide by 8. What do we get? 7.5. Okay, so I just solved that like I normally would. Do you have any questions about that part?
So 60 equals.
Okay, then cover this up. Do the same process over here. When you cross multiply, you're going to get 36 equals 8A. Divide by 8. 4.5. Okay. The hardest part is separating the two triangles. So be sure you look back at this problem and make sure you know how to separate the triangles. Let's find the length of the altitude drawn to the hypotenuse. Okay. I have two triangles here, two right triangles. I have a large one. In the large triangle, the hypotenuse is 37. All right? I have a small triangle over here. It's 7. And then I have a triangle here that's 30. This is X. And I'm going to draw the smaller triangle here. 7. And that's also X. It's the same segment, right? Y'all believe that's the same segment? Okay. This is a right triangle, which this is also a right triangle. Okay. So, let me think a minute here. Let me try this. long side, or what side matches up with 7 from over here? X. X over 7 equals 30 over X. You with me? Cross products. X squared equals 7 times 30. X squared is 210, so you got to take the square root. So X is the square root of 210. Number 16. Given that PQ is parallel to BC, that forces those triangles to be similar. Find the length of AQ. So I want X right here. So here's the small triangle. It's 5 and it's X. Here's the large triangle. It's 25 and Q plus, not Q, X plus 32. Right? So 5 is to 25 as X is X plus 32. Here we go. 5 times X plus 32 equals 25X. 5X plus 160 equals 25X. Subtract the 5X. 160 equals 20X. Divide by 20. What do you get for X? 8. X is 8. 17, solve for X. Let's see. 4X, or 3X is to 4X, as 3X plus 7 is to 5X minus 8. Cross multiply. 3X times 5X minus 8 equals 4X times 3X plus 7. 15X squared minus 24X equals 12X squared plus 28X. Don't let me make a mathematical error as I work here. Move everything to one side. It's going to say 3X squared minus 24X is 28X. Subtract the 28. 3X squared minus, what's that, 28 and 24, 52X equals 0. Common factor here is 3X. Pull that out. And you're left with X minus how many? 17 and a third. So set equal to 0. 3X could be 0, or X minus 17 and a third could be 0. If 3X is 0, X is 0. If X is 0, do these have any length? No. Or if X were negative, would it make sense? No. So you could throw that one out. That one's not going to work. But here, if you solve, you get X equals 17 and a third. Does that make sense? Could it actually be 17 and a third? Yes.
I'm still on the line.
Let's go over to 20.
Did you work that Sunday instead?
No. Let's go to 20. The figures are similar. Give the ratio of the perimeters and the ratio of the areas. What's the ratio of the perimeters? The perimeters is going to be the same ratio as the shape. So what would that be?
5 to 2.
You start out with 25 over 10. You simplify it to 5 to 2. That's for the perimeters. What about the ratio of the areas? What's going to happen when you find area? How do you find area? What do you multiply together?
Based on type.
Right. So whatever that ratio is, you multiply it by itself. You use it twice. If you use it in the length and then again in the width, or the base and the height, either way, you're going to multiply it twice. So the ratio of the areas is the ratio of the original squared, which is 25 over 4. Make sense? That's a 2.
What's this?
The ratio of the figure squared gives you the ratio of the areas. Okay? Make sense? The width of two similar rectangles are 6 and 16. What is the ratio of the perimeters? What are we going to write? We're going to start with 6 over 16, and we're going to simplify it to what? 3/8. That's for the perimeter. What about the areas? Nine over 64. These figures are similar. The figures are similar. It's 18 to 14. Can you simplify that? 9 to 7. The area of the larger is 310. This is the ratio of the figures. What's the ratio of the areas for these particular shapes?
So you plug 310, it's 81 over 9.
81 over 49 equals 310 over something.
Okay, and what are we on?
I'm on number 22. So 310.
Huh?
I got approximately 188 feet squared. A rectangular napkin is 325. A similar tablecloth is 5 times as long and 5 times as wide. How much would you expect to pay for the tablecloth?
5 times more.
5 times more?
I put 5 times more just because it's just a lunch expense.
How many napkins would it take to make the tablecloth?
About
So it's
80.
25?
25 napkins.
Oh,
So the price
25.
is
25 times more.
I kind of guessed it around 25. I just go with 24. It was 25.
and that price is $81.25. The altitude, we're not going to do the altitude problem. We're not going to do the circle problem. I just wanted y'all to think about those.